Today we have discussed about the session of elasticity and the topic of Young's modulus. So today we discuss the topic of Young's modulus elasticity to determine the wooden scale. So Young's modulus have two different types of models work nature. One is uniform bending model and another one is non-uniform bending model. So today we discuss about the two different types of Young's modulus models. Okay. So first of all we sketch the scale, wooden scale in the knife edges. This is two knife edges. It's placed between the 1 meter scale. 1 meter scale it means 100 centimeter scale. In the center of the scale 50 centimeter we attach the needle of this material. We focus the needle with the uses of microscope. In this microscope we take a different material. It's a practical markings. And now we input the weighted of each end, the centimeter of tape. It's a uniform method, so we stitch the knife edge at 20 centimeter each right and left portion, and we include the weight hanger at the centimeter of 10. In this in between gap the scale will be bent. If we add two different types of weight, this is a 50 gram weight. So we input both sides in the 50 gram. The scale will be come U-shaped curve. Or which type of curve it's attained? Which type of curve uniform bend will be attained? Both sides the weight is stitched. In center point the scale will be raised or bending method we have. So first we check the initial adjustments of microscope. So first adjustments of initial adjustment to take the zero position microscopic value. So first we needle is focused now. The needles are shown in the opposite direction. In this microscope have a 4 directions of graphical approach, x-axis and y-axis. In middle of x-axis we put the needles edge at the center point. Each and every time we input the weight, the scale will be raised upward movement. So that time we have to change the position of this needle edge and then we take the reading of this microscope. So first of all we take the insert the weight at each place. In this uniform bending method, it's a elasticity material. So if we insert the weight, the scale will be raised at small portion. In this place we are not seeing a normalize. So we take the microscopic structure. First we input the another 4 different types of weight. The scale will be raised evenly, and then we take out the weight. It's a unloading method. This is loading method, and then we input each and every side at same loader. Don't take the one side only higher weighting method and another side of higher weighting method. So we gradually increase both sides. The scale will be raised to center position. All the weights are hanged. Then we remove the weights. Even all the both weight hang. So we take all the weights. Now the scale comes down to 0 position at the weight of this level. This is the elastic. If the scale is not come to 0 position, this is the elastic material.